If the right pedal is at its stop and the pitch of the blade is more than 24 degrees, set the stop accordingly. If the right pedal is at its stop and the pitch of the blade is less than 24 degrees, recheck and verify the tail rotor cable range of travel is 2 7/8 inches. The rod end on the pitch horn should be centered over the 3/8 inch bolt holding the barrel to the shaft. Use washers if necessary to achieve this alignment. If more than 4 washers are required to position these rod ends, contact Rotorway Technical Support. Safety wire the bolts of the tail rotor assembly as shown. You will need to drill a small hole in the carriage slider assembly to safety wire these 2 bolts. The purpose of the tail rotor drive is to keep the tail rotor turning at the correct RPM. If the tail rotor drive is not installed or adjusted correctly, the pilot cannot correct for torque and maintain control of the helicopter. When rigging the tail rotor drive, do the following. Check to ensure that the idler pulley mounting scissors at bulkheads 2 and 3 can pivot freely. If you have not installed the belts, do so at this time. Fully loosen the nuts on the all-thread adjustment rods so that the belts are not under any tension while being installed. Never install a belt by rolling it into place over the edge of a pulley while under tension, as this can damage the belt internally. To adjust the belts, first loosen the rear 1/4 inch bolts on the tail rotor shaft bearing flanges. Then turn the 5/16 inch nuts on all the all-thread rods clockwise to tighten the belts. Initial tensioning. Check the tail rotor drive belt tension at the front of the number 1 bulkhead. Push the belt with the belt tension tool until it indicates 10 pounds. Use a ruler to check the distance that the belt moves. Adjust the tension until it deflects 1 3/8 inches at 10 pounds. Do not over-tighten the belts. When the belts are at the correct tension, retighten the 1/4 inch bolts on the bearing flanges. Check the rear drive belt tension by inserting the tool in a small hole towards the rear of the tail boom on the passenger side. Push up against the belt until the tool indicates 10 pounds. The tool must not make contact with the tail boom skin, or an inaccurate reading may result. Holding this position, make a reference mark on the tool at the edge of the hole. When checking belt tension in the future, push the tool against the belt until the reference mark aligns with the edge of the hole. The tool must indicate between the tight and loose limit marks. The belt replacement label can be installed once the initial tension has been attained. Apply the label to the upper tail rotor slider stringer on the pilot's side. Align the new belt mark on the label with the rear edge of the bearing mounting plate. If the bearing mounting plate reaches the replace mark during subsequent adjustments, this is an indication that the belt is stretched beyond a safe limit. Any belt that is stretched more than 1 inch may be damaged internally. It must be replaced immediately, regardless of the number of hours it has been used. Make sure the temperature strips are installed on the 2 tail rotor idler pulleys and the drive pulley on the tail rotor shaft. The heat-sensitive dots will darken if the indicated temperature is exceeded. Examine the temperature strips before and after each flight. If the 170-degree dot darkens, it is an indication that a belt may be slipping or some other problem may exist. The problem should be identified and corrected before continuing flight. If the 180-degree or higher dot darkens, the belts have been damaged from the heat and must be replaced. Upon installing new belts, check and adjust the tension every 15 minutes that the engine is running, either idle or operating RPM, until no further adjustment is required. New belts will stretch rapidly during this time, and it is very important to prevent them from becoming too loose. A belt that is too loose can be damaged internally by rolling over the edges of the pulleys. It can also be damaged by the heat created from excessive slipping. Any belt that is rolled may be damaged internally and must be replaced immediately to prevent failure. The belts and pulleys should be kept clean and free of any oil, dirt, or other contamination. Use acetone and a clean cloth, damp but not dripping with acetone. When belts have stopped stretching and been tensioned for the final time, drill a 3/16 hole through the bearing plate assembly and the slider rail on the pilot side only, and install a 3/16 bolt. This is a safety bolt hole in case of adjustment rod failure. The main rotor blades are wings which lift the helicopter and pull it in the direction that you are flying. When the two blades are made the same and are adjusted so that they lift the same amount, the helicopter is a smooth flying machine. Rig the rotor system as follows. The rotor hub plate must be shimmed correctly on the main shaft. Center of the outboard pitch pins and the center of the main shaft must be in a straight line to within 5/10,000ths or a total indicator reading of 1/1000th of an inch. The main rotor shaft should be 90 degrees to the ground in all directions. The center of the 9/16 retention bolt should be 1.985 to 1.990 from the leading edge of the rotor blades. The thrust block should be installed correctly on the rotor hub. Both rotor blade cord lines should be level, with the control rod disconnected. Both rotor blades should be the same weight. Both pitch horns should be mounted to the retention strap the same. Set the pitch on the rotor blades using the control rods, with the swash plate 90 degrees to the main shaft. With the collective full down, both blades are set at 2 degrees negative pitch. Check the pitch on the main rotor blades when the collective is in the full up position. The pitch should be 9.5 degrees to 10 degrees positive. When the collective is at its stop in the up position and the pitch measures more than 10 degrees, it will be necessary to modify the stop on the airframe. Bolt a piece of shim stock to the bracket to adjust the correct pitch. This is necessary as too much pitch would produce rotor RPM decay. The teeter travel must be between 14 and 15 degrees total movement. If your blades are not installed at this time, do the following. Clean and apply a thin layer of the recommended grease to the inboard and outboard pitch pins. Install the thrust blocks with the master block on the end of the hub with the serial number. Check the fit inside the hub. Using the procedures in Section 24, install both blades to the rotor hub. Remember, the blades must be held in a pre-coned position and not allowed to droop until both 9/16 bolts are installed and tightened. Level the rotor hub laterally. If necessary, shim under the skids to level the hub. When the rotor blades are hanging unsupported on the hub, the blades must feather freely to do a static lead-lag adjustment. Loosen the 5/16 aligner block bolts and the Allen screws. Use the all-thread 1/4" bolt to level both blades. The blade sweeps on the 9/16 retention bolt and pivots on the inboard and outboard pitch pins. When the blade is aligned with the pitch pins, it will level itself if it is free to pivot on the pitch pins. Check that the slave blade is level. Check that the master blade is level. The hub plate, master blade, and slave blade should be level when all the bolts are tight and the static lead-lag balance is done correctly. Check to see if both main rotor blades are the same weight. Replace the 3/8 inch bolts in the teeter block with 1/4 inch bolts one at a time to allow the hub to teeter freely. Place the level on the hub plate under the main drive pin so the weight of the level will not affect the balance of the blades. The blades should teeter freely and return to the balanced position. If they do not, remove weight from the tip weight of the heavier blade until the bubble centers. Be sure the wood end plugs and their screws are on the ends when checking the balance. When the balance is correct, install the tip plugs in the end of the blades, securing them with structure adhesive and wood screws. Remove the 1/4 inch bolts and reinstall the 3/8 inch bolts in the teeter blocks one at a time. Verify the position of the pitch horns. With a long 5/16 inch bolt ground to a point, install it in the pitch horn clevis. Raise the pitch horn and verify that the point aligns with the center of the drive pin. Reinstall the control rods and adjust them so that the swash plate, rotor hub, and both rotor blades are level. Slide the rubber collar down as far as possible and check the distance between the main shaft and the control rods. Both sides must be equal. With the rotor blades, rotor hub, and swash plate level, verify the pitch of the main rotor blades. Collective down both blades should have a 2-degree negative pitch. Collective full up, both blades should have a 9.5 to 10-degree positive pitch. Verify that the collective and the cyclic do not interfere with each other. Look closely at the pitch horn clevis and the rod end on the control rods. They must have adequate clearance in all control positions. It may be necessary to file the clevis slightly so the rod end does not bind against the clevis opening. Also, make sure the thrust blocks and blade straps do not interfere with the hub plate in all cyclic and collective control positions. The main drive belts turn all the rotating parts in the helicopter. If the belts are dirty or loose, they will slip and the parts will not turn at the correct speed. When this happens, the helicopter will not fly. To verify the belts have been installed correctly, do the following. The belts and pulleys should be clean. Use acetone and a clean rag. The rag should be damp, but not dripping with acetone. To verify the pulleys are properly aligned, level the secondary pulley by shimming under the skids. Level the engine flywheel by moving the top or bottom of the engine. Remove the bolt that holds the rod end to the clutch arm casting and the top belt of the fan countershaft drive. Make a mark on the side of the engine pulley, 200 thousandths from the top of both sides of the aircraft. This is necessary because the top of the pulley has approximately 200 thousandths more material above the belt grooves than the secondary pulley. Remove the pivot bolt that holds the clutch arm casting on the passenger side. This is necessary so you can move the arm out of the way to use a straight edge on the pulleys. Place a straight edge on the top of the secondary pulley. The straight edge should be even with the mark on the engine pulley. Reinstall the clutch arm and place a straight edge on the secondary and verify the idler pulley is level with the secondary pulley. The pilot's side is the tension side of the pulley, so if you have to choose one side to be perfect, use the pilot's side. Be sure the belts are at the proper tension. Caution, do not over-tighten the belts. Achieve the correct tension and adjust as necessary to maintain the correct tension. Apply 7 pounds of pressure with a spring scale to one drive belt on the pilot side. It should move 1/2 inch. The idler pulley should not be touching the belts when making this test. Install the bolt that holds the rod end to the clutch arm casting. Note, it is important to maintain clearance between the clutch tube and the square drive tube. When the clutch is engaged, the piston in the spring tube should move 1 inch. Make sure the pivot arm bolt, the piston, and the springs in the spring tube have been greased. Verify and make sure the clutch arm casting does not touch the piston tube. The swash plate is a disc that, when tipped at an angle to the main shaft by the cyclic control, makes the main rotor blade tip to the same angle. The swash plate tips the main rotor blade in different attitudes to maintain balance of the helicopter in flight. When rigging the swash plate, do the following. All angles of the swash plate are set in reference to the main rotor shaft. Note, use shims under the skids until the main rotor shaft is 90 degrees to the ground, both fore and aft, and laterally. When the cyclic handle is against the forward stop, the swash plate must tip forward 5 to 5.5 degrees down in the front, in reference to the main rotor shaft. When the cyclic handle is against the rear stop, the swash plate must tip 5 to 5.5 degrees down in the rear, in reference to the main rotor shaft. When the cyclic handle is against the left stop, the swash plate must tip 5 to 5.5 degrees down on the left, in reference to the main rotor shaft. When the cyclic stick is against the right stop, the swash plate must tip 5 to 5.5 degrees down on the right, in reference to the main rotor shaft. The cyclic cables are to be adjusted with a bias as shown. Using a spring scale, pull 4 pounds to align the rod end with the slot of the swash plate to give the correct bias on the control cables. When the correct bias is achieved on the control cable, install the rod end in the swash plate opening. Both the lateral and fore-aft cables must have the correct bias. When setting the swash plate angles, the main shaft must be 90 degrees to the ground. Put 2 5/16" bolts in the holes and place a straight edge on them. Set the protractor level 5 to 5.5 degrees and set it on the straight edge. Center the cyclic fore-aft and against the left stop. Adjust the rod end until the bubble centers. Set the protractor to 5 to 5.5 degrees in the other direction and place it on the straight edge. The cyclic control should be centered fore-aft and against the right side stop. The bubble should center. If it does not, the ratio of the cyclic and swash plate is off. Check the moment arm at the end of the cable. The moment arm is the distance between the pivot point and the attachment point. Remove the long bolts and rotate the swash plate to check the fore-aft angles. Install the long bolts and straight edge. The cyclic should be centered laterally and against the forward stop to set the angle. Set the protractor to 5 to 5.5 degrees and place it on the straight edge. Adjust the rod end until the bubble is centered. Set the protractor to 5 to 5.5 degrees in the other direction and place it on the straight edge. The cyclic should be centered laterally and against the rear stop. The bubble should center. If it does not, the ratio of the cyclic and swash plate is off. Check the moment arm at the end of the control cable.